Okay, so this is the answer to one of the examples. So example 3, find the total resistance and whatever's missing in the circuit. So looks like it's the ammeter and voltmeters in some of the questions. So for this first one here, what's the total resistance? Well, these two are in series, so resistance total equals R1 plus R2, so that will just be 2 plus 2. Now in terms of what is the ammeter value there, well, it's just going to be total current is equal to total voltage divided by total resistance from V equals IR. So that will just be 12 divided by 4, so equals 3 amps. Now, let's get rid of all that. Looking at the next one, 3 in series, this one here we're looking at. Okay, so we've got 3 in series, so resistance total will equal R1 plus R2 plus R3. So that will be equal to 20 plus 10 plus 2, so that equals 32 ohms. Now, so working out the total total current will be the best way. Oh, it's already done for you, so it's 0.750. So working out what this voltage is, well, if we've got 0.75 amps going through that resistor, then we could find out the potential difference across it using V equals IR. So that will just be equal to 0.75 times 10, I think it is, and that's 7.5. Now, what's the total voltage there? Okay, well, if it's 7.5 there, you could actually just do that current multiplied by the total resistance to give you 24 volts. Okay, so V total equals I total times R total, so that will be 32 times 0.75, 24 volts. Okay, so next one. Now we've got parallel. So up the top here, 2 ammeters missing, that one and that one. If this is 1.2 amps, and that looks exactly the same, this has the same potential difference across it as that one. Okay, because this whole side here is 24 volts. Okay, this whole side is 0, so there's 24 volts lost on that one, 24 volts lost on that one. So there's the same push through the same resistance, okay, or same amount of energy drops through the same resistance, so the rate of flow will be the same for each. So the answer there will be 1.2 amps. What's the total? Well, Kirchhoff's first law will tell you that this current going into this junction is the same as the total current leaving. So if 2.4 is leaving, there must be 2.4 going in. What is the total resistance? Well, it's just going to be 1 over R total is equal to 1 over 20 plus 1 over 20. Should do the formula, I suppose. And so on. Okay. Now, so this should just make 2 over 20. That's handy. But that's what 1 over R total equals. So let's invert it and find R total over 1. And that will be 20 over 2, so that is 10 ohms. Okay, so next one. All of these have the same potential difference across it. Let's just find what that potential is first, shall we? The potential across this one there, 1.2 amps flows through it. 20 ohms is your resistance, so it'll just be V equals IR. It will be 1.2 times 20, so you can go from there. Now, what's this current here? Well, this is going to be 2.4 plus another 0.4, so that makes 2.8 amps. It's pretty straightforward. What is the total resistance? Well, we're going to do 1 over R total is equal to 1 over 20 plus 1 over 20 plus 1 over 60. Need a common denominator, so you can make it 60, so that makes 3 over 60 plus 3 over 60 plus 1 over 60, so it's 7 over 60. Our total divided by 1 is equal to 60 over 7. So that is 8.6. And that's it.